So this is the statement. We have a hexagonal prism of 30 mm sides and axis 80 mm, which is resting on HP on one of its corners of the base. The axis makes 30 degrees with HP, and the plan, also called as top view, of the axis makes 45 degrees with VP. Draw its projections. So XY line, since the hexagon is supposed to rest on a corner, so you need to draw it like this, opposite corners on either side, and A, B, C, D, F are the corners of the base, and 1, 2, 3, 4, 5, 6 are the corners of the top face. So draw the vertical projections, and you can locate the corners of the base as A, B, C, D, F. Then draw the projections, extend them above XY line, and you will get the corners of the top face 1, 2, 3, 4, 5, 6 along with the axis. Now you are going to see three rectangular faces in the front view, and they are A1 to B, that is this face, B2 3C, that is this face, and 3CD4, that is this face. So three rectangular faces are seen in the first step, front view. Second step, you have to incline the axis by 30 degrees to HP. That means the base is inclined by 60 degrees, and when you are inclining, the solid should be resting on HP on its corner B, as can be seen. Now the point to be noted here is, since the inclination of the base is 60 degrees, which is less than 90, so the base won't be seen in the top view. However, since the inclination of the top face is more than 90 degrees when you take the inclination with respect to XY line, the top face will be seen in its top view. So let us find out. Draw the vertical and the horizontal projectors, locate the corners of the base, and then the corners of the top face, and then what you see here is, you will see the top face clearly 1, 2, 3, 4, 5, 6, and the base will not be seen, so you have to represent it by hidden lines. Now along with the top face, you are going to see two rectangular faces. So this rectangular face will be 6, 1 AF and 1, 2 BA. In third step, you have to incline the axis, that is the top view of the axis, by 45 degrees. So this 45 degrees is an apparent inclination, and the top view of the axis, if you observe, the front view of the axis is the true length 80 mm. In the second step, top view, you will see that the 80 mm has reduced, and now if you see, it is no more 80 mm. So this length of the axis in the second step, top view, is an apparent length. So you can keep an apparent length on an apparent inclination. It is not a locus problem. Okay. So when you incline the axis at 45 degrees, you will see that the top face is nearer to the observer and the base is away from the observer. So in the final front view, you are bound to see the top face clearly, and the base won't be seen. Let us find out. Draw the vertical and the horizontal projectors and represent the corners of the base ABCDF, and then the corners of the top face 1, 2, 3, 4, 5, 6. Complete the projections and draw the hidden lines and the solid lines, and what you get is the top face is clearly seen, that is 1, 2, 3, 4, 5, 6. The base ABCDF is not seen, so you represent it by hidden lines. Now along with the top face, what is seen are three rectangular faces. The first one is this 2BC3, the second one 3CD4, and the third one 4DE5. So in the final front view, you are seeing the top face and three rectangular faces. So this is a problem on hexagonal prism resting on a corner. I hope you understood it, and please try it out as part of the assignment problem. I'll be back.